PTB Course Unit 2 Walkthrough. In this short walkthrough, we will demonstrate scope management with the PTB. The project initiation phase is done with the Scenario Builder tool, which allows us to model the project. At this stage, the project manager has already identified the needs and expectations of the different stakeholders. Begin by opening the scenario elearning/walkthroughs/unit2.scn. The Activity on Node diagram, or network view, is the first screen we see. In this screen, we can see the project scope as a list of activities or tasks that should be performed in order to satisfy the needs and expectations of the stakeholders. The arrows represent precedence relations between the tasks. When all the tasks are completed successfully, the project scope is completed as required. Another way to view the project scope is by pressing the Tasks button. In this view, we can see the different tasks, their predecessors, and the work package to which they belong. The tasks are assigned to work packages according to the work breakdown structure of the project. In our case, there is one work package, WP1, and 7 activities or tasks. The product scope is presented in the PTB as a list of requirements based on the mapping of stakeholders' needs and expectations. These requirements can be seen by pressing the System Requirements button. In this scenario, there is one system requirement, quality of software. A formula is used to calculate the actual score of the requirement. Based on this formula, the user knows how the actual value of the requirement score is calculated. In our example, the quality of software requirement is evaluated according to 5 different parameters. These parameters are HDQ, hardware design quality, SDQ, software design quality, HMQ, hardware management quality, SCQ, software coding quality, IQ, integration quality. The values of these independent variables is determined by the modes or alternatives selected to perform the relevant project task or activity, as we will soon see. Each requirement is assigned a relative priority or importance. This is a relative weight on a scale from 1 to 10. In our case, the quality of software requirement has a value of 10, as it is of utmost importance. These weights are used to calculate a performance measure known as the benefit of the product or system produced by the project. The benefit is a measure of the value the project creates for the stakeholders. When planning is completed and modes are selected, the actual score of each requirement is evaluated. The benefit is calculated by multiplying the score of each requirement by the relevant weight and summing up all the requirements. Each requirement value has a range. In our example, the range is between 0 and 1, and the goal is to maximize the value. If at the end of the project the actual value is less than 0, it means that stakeholders' needs are not satisfied. If it is higher than 1, it could mean that we are over-designing or gold-plating. Begin planning the project. Click on the task Hardware Design. The task has 2 alternatives or modes for execution: in-house hardware design and subcontractor A. Each mode has associated characteristics. The first one is the duration of the task. The second characteristic is the fixed cost, 0 in our case. The third characteristic is the resources necessary. In our project, there is only one resource type, worker. Mode in-house hardware design would require 2 worker units per time period, while mode subcontractor A does not require any workers. The fourth characteristic is the quality parameter HDQ, or hardware design quality. If we choose the first mode, it will get a value of 0.95. If we choose the second mode, the quality parameter will get a value of 0.9. Our choice of alternative for executing the task will affect the task duration, resource requirements, cost, and quality or product scope. In our example, the in-house mode is more expensive as it requires using our own resources in addition to the fixed cost, but it would yield a better hardware design quality. This is the essence of project integration management. Trade-off analysis should be performed to evaluate the trade-offs between the various performance measures, time, cost, resources, and risk. Plan the task by changing the status from unplanned to planned and select the mode Subcontractor A by clicking it. By default, the task is planned to its earliest possible start time, which is 0 since it has no predecessors. Instead of manually planning the rest of the tasks, create a default plan by pressing the Plan Default button. This naive algorithm chooses the earliest possible start time for each task with the cheapest mode. Now that all the tasks are planned, let's see the evaluation of our system requirements. We can see that the evaluation is 0.57, which is lower than the desired value of 1. This means that our plan should be improved in terms of product scope. Try to improve the plan by clicking on the task hardware design and changing the mode to in-house hardware design. Now go back to the system requirements view. The evaluation of the quality of software improved from 0.57 to 0.6. Your assignment is to open the scenario elearning/exercises/unit2.scn and to create a feasible plan for this project. After you create a plan you are satisfied with, advance the simulation time as we learned in the previous unit until project completion. Remember to manage the changes. If you change a mode of a task, check what the consequences and the impact on the system requirements are, as well as the consequences on the project duration and cost. Good luck!